So, hello and welcome everybody to the German testing board track at the A4Q testing summit live from Marrakesh. So apparently we had some technical difficulties here, but when testers use productive systems, this may happen that everything breaks down, but now we are on. So good to have you here, everybody. The German testing board is one of almost 70 national boards of the ISTQB. We are happy to be the host of the following 4 presentations by members and friends of our board. Our board, the German Testing Board, like the ISTQB, is celebrating its 20th anniversary this year. So in fact, the German Testing Board is one of the founding members of the ISTQB. My name is Florian Fieber. I'm the chairman of the GTB, and I'm happy and excited to moderate this track for the next 4 hours. So if you have If you have any questions about the presentations, please just post them in the chat, and after the presentations, I will then discuss your questions with the speakers at the end. So now I wish us all a lot of fun and exciting and interesting insights during the next 4 hours. First of all, I would like to welcome Matthias Hamburg, who is sitting right next to me. Matthias will speak on metamorphic testing today. So Matthias is an active member of our board of the GTB. He's also very active in the ISTQB, where he is the chair of the glossary working group. Since 2019, Matthias is also the product owner of the advanced level test analyst syllabus. In his professional career, Matthias was active as a senior consultant and trainer for Sogeti. He's now retired, but that doesn't mean that he has settled down. On the contrary, he's still very active as a test manager and a member of various GTB and ISTQB working groups. So I'm very happy to welcome you, Matthias, with your talk on metamorphic testing.
Thank you, Florian, and hello and welcome to everybody out there in the world from our current ISTQB General Assembly site in Marrakesh in Morocco. Today I would like to talk to you about metamorphic testing. I assume that not many of you have heard about this type of testing. And so that's my motivation. That's why I wanted to explain metamorphic testing to you. So metamorphosis is a Latin word meaning the transformation of shape. And metamorphic testing is based on the transformation of the shape of test cases. In the beginning, I want to explain you the basic problem that should be solved by metamorphic testing, the oracle problem in testing. Then I will explain you how metamorphic testing works with a known example. Subsequently, I will present a couple of other examples from practice mainly, and then we will come to a test methodology classification and to the conclusions. So what is the oracle problem in testing and solutions to the oracle problem? When we are performing dynamic testing, we feed inputs to the test object, we obtain actual results, and then we have to compare them with the expected results to decide whether the test case passed or failed. So in order to do it, we need something called a test oracle. That's the procedure that derives the expected results from the inputs. Oracle is yet another Latin term. You probably have heard about it. Here is a wonderful ancient Greek vase or plate, I think, a painting with a priest reading from her tablet the expected results to a brave tester. This test oracle is often a problem. We are rarely in the lucky situation to have an automated test oracle, which is generating the expected results automatically from the inputs. For instance, in the case of a software migration where the legacy system might serve as such, but usually just by reading the specification it's not always easy to derive the expected results. So this is the classical Oracle problem, which has been there in software testing since old times. And my starting point will be a publication, an article published by Lindvall, a well-known American software expert, who has written an article back in 1982 about testing non-testable programs, which was published in the Computer Journal. She meant by non-testable programs the programs that lack a test oracle, so you cannot decide whether the actual results are correct or not. And she presented 3 different solutions to the oracle problem that were known by that time. The first one that is still in use today and very popular is to restrict the testing to certain inputs for which you can easily deduce the expected results. That's what we usually use in manual testing of IT systems, but it has a main shortcoming, which she mentioned in her paper, that is that very often defects are hidden behind complicated inputs for which we do not have the test oracle. So we're not very effective in defect detection if we just restrict our inputs to the easy ones. So there is another approach which tries to compensate for that, and that is to develop a second or even several solutions to our test object, which will predict the expected results. This has, of course, as a main shortcoming, the cost. So that's why this solution is mainly used in safety critical problems where the investment upfront is worthwhile. And the third solution that she mentioned there was called by her a pseudo oracle or a partial oracle, sorry. The partial oracle is not completely checking the correctness of the actual results, but just some properties of it. Today, it's very well known under the name of property-based testing. So some outputs might have to be greater than an input value, or the dates have to have some certain relationships. And this is property-based testing, which could be the subject of a separate presentation. And in conclusion, after having presented these 3 solutions known by that time, Lindvall concluded that it is a major task for research and development to find additional solutions, better solutions to the oracle problem. However, for a longer period of time, not much happened until metamorphic testing came up. And metamorphic testing is based on the principle that you check the consistency of several test cases among each other, which are related with each other. So let me explain that with an example. Since I am the working group chair of the glossary, as Florian mentioned, I am the product owner, so I have to maintain the glossary database. And that means that not only we have to maintain it when new terms are introduced, but also whenever a new syllabus is introduced in ISTQB. Why that? Because we want to provide the feature to filter by terms used in a certain syllabus to support exam candidates and readers of that syllabus with the specific definitions of the terms used in that. And for maintaining the syllabus, we run a program called the ISTQB Glossary Checker, which reads the new syllabus. In this case, it was the foundation level syllabus published in 2019. And also reads the glossary terms and checks which terms are used in that syllabus, marks them in a relational table, And in addition, our software also detects whether a term is mentioned as a keyword at the beginning of the chapter. If you have seen syllabi, you might be aware of this, that at the beginning of the chapter, the most important testing terms are listed in a section called keywords. So this relation table is filled up, and this software has been developed for the German testing board by 2 students a couple of years ago, and I don't trust it really. So whenever I run it, I have to check the consistency of the outcome. So let's test it, but we have an Oracle problem. So let's test it using metamorphic testing. In metamorphic testing, you start out with a so-called source test case. The source test case is a test case that you run to have a basis for comparison with subsequent test cases. In this case, I've chosen a simple search of a text for some text string. In this case, I've chosen test as a test string, but you might have chosen any other strings. And we run this test case, and as an actual result in our application, we see that there are 226 terms which contain the string test. That looks fine out of the total of 590 terms in our glossary. So that was the source test case. We do not check whether the results are correct or not. We just assume it's passed. Now we transform this test case, and the transformation is called the metamorphic relation. The first metamorphic relation that comes to my mind is that we can filter the search by terms which occur in this new syllabus. Now it becomes more interesting because it's related to the program that I just ran. So the metamorphic relation tells us that the result of the filtered search has to be a subset of the original result of the source test case, right? So let's run it, and we find 112 terms. How do we check whether these 112 are a subset of the previous set? Well, I ran a comparator and checked it automatically. So the metamorphic relation 1 is satisfied by our software in this case. So metamorphic relation 1 passed. Now I turn this follow-up test case, we call it follow-up test case in metamorphic testing, into the source test case of our next metamorphic relation, because I noticed that we can add yet another filter, filtering not just for terms used in this foundation level syllabus, but also marked as keywords. And there is a second option, just to search for terms that are not marked as keywords. So keywords only and non-keywords only. And the second metamorphic relation would tell us that the two results should be a partition, should partition the previous set, right? So we are expecting two disjoint subsets which have to build up the entire set. Okay, so let's run them, and we find two lists. The keywords start with acceptance testing, the non-keywords with test and accessibility testing. That all looks reasonable, but now wait a minute. We can notice that we have 64 keywords only and 42 non-keywords only, adding up to 106. But before, in the source test case, we had 112 results. So it's not covering the complete original result. We expected 112 in total. This means that the second metamorphic relation failed. Or to be more precise, the software failed to fulfill the second metamorphic relation in this case. 6 terms are missing, right? And that is how metamorphic testing is working. Of course, the next step would be to debug. As a product owner, I know the structure of our database and I know how things should look like, but I don't want to explain you all the details. I just found by a SQL query quickly that the 6 terms missing have these terms IDs, and then I found actually the root cause of the defect is that our program has entered invalid values too for those keywords that are appearing, or those terms that are appearing as keyword in 2 different chapters of the syllabus. So these, by that I could remove the defect, and now it's working properly. Don't search for that defect anymore. So this is how this example should explain you how metamorphic testing runs. Now let's see how metamorphic testing is used in practice and by others. I will present a couple of case studies published, but I will start with an overview of the publications about metamorphic testing. The original publication about metamorphic testing has been published in the technical reports of the Hong Kong University, written by a group of Chinese researchers back in 1998. And of course, not many people are reading the technical reports of the Hong Kong University. I don't do it either. But these people didn't get tired in advertising for their method. They were the people also who named this technique as metamorphic testing. And they went to several conferences and talked about their technique. And little by little over the years, it became better known, but it's still not very well known. In 2018, a group of researchers from the Spanish University of around Segura have conducted a survey of publications and published it in 2018, where they are listing 84 case studies about metamorphic testing, demonstrating the success. The diagram here in this picture shows the distribution of these case studies across different application domains like web services, like computer graphics, and so on. Today, I would say that artificial intelligence should be one of the major slices in this diagram. And a joint paper by Segura, Chen, and some other researchers has been published recently in 2020 in the IEEE Software magazine, which is better known than the Hong Kong University reports. So there are a number of case studies, and indeed 1 year later, after this publication in 2020, the new version of the ISO standard for test techniques has been released. As you know, the standard series 29119 has different parts about different aspects of software testing, and part 4 is dealing with test techniques, and this test technique is already defined in there in 2021. So it recently became a sort of standard. We did not include it yet in the ISTQB Advanced Test Analyst. As Florian mentioned, I am the product owner of that syllabus because we didn't publish a major update yet. But the new ISTQB syllabus for testing artificial intelligence-based systems is already treating this technique. So let's see 4 of the publications or case studies mentioned in this list of 84. The first one I want to mention was conducted by a group of testers from the American branch of the Fraunhofer Institute. And their test object was the NASA Data Access Toolkit. So the NASA is, of course, flying many space missions, and they are collecting the so-called telemetry data. So these are data metrics collected during the space flights and transmitted to the ground station and stored in databases. And the NASA Data Access Toolkit is a high-performance query and research user interface to research among the data of past missions to develop new missions. And it's, of course, very important to have very accurate results in these searches, right? But the database is huge, so they are really facing an Oracle problem here, whether the query results are accurate. And these testers conducted this test in acceptance testing, and they transformed original queries by transforming them with equivalent Boolean expressions or transforming the format of different data, expecting the same result sets. And they indeed report that they have successfully detected a large number of defects in this way with this technique. And they also mentioned that it was very well suited with agility because the project was an agile project developing in many increments and with model-based testing. The next example I wanted to mention was 1 year later, a study conducted on the reliability of the most popular search engines like Google, Bing, and there is a Chinese version of Bing by Microsoft and Baidu, which is the original Chinese-made search engine. Here we have a similar Oracle problem because the database is again huge and changes all the time. So how reliable are these searches? And what the testers did was they transformed the search. They ran a source test case with a searching for some input, and if they obtain a result list, then they restrict the search to some specific attributes of some top hits in the result list, like the URL domain of the first result, right? So the first result coming from, in this example, in this picture, the first result was coming from Australia. But if you restrict the search to Australian pages, then it is not shown anymore. So their result was that none of the search engines that we use every day is 100% reliable. Of course, there were differences. In English, Google was better. In Chinese, Baidu was better than the others. But they detected several defects. And I found it very interesting because this is a purely black box test technique in this case, right? Because the algorithms are kept secret by the providers, and they had just to test black box, and they ran their tests for a long period of time to evaluate the reliability of these engines. 1 year later, the same group as before, Lindvall and his colleagues have tested the safety of autonomous drones. And this is the first example of an artificial intelligence-based system, the drone artificial intelligence controller, which was, of course, tested in a simulated environment. You don't want to fly the drones against the obstacles. And it was, I have to tell you, it wasn't warfare drones, of which we are talking very much nowadays. It was, they were drones for package delivery. So they had to fly a package to a destination and then come back and avoid obstacles. So the question was in the Oracle problem whether the autonomous drone behaves safely and as expected on the way. And they took a source test case which passed, and then they did variations to the exposure to light. They rotated the scenery, they translated it, and so on. And here is an example from that paper where a drone started off from the point on the bottom left. Actually, this is not the original source test case because the original one has the destination to the north and 3 obstacles in a semicircle in the middle. Right, so but they noticed that if they rotated it, it took the same route, avoiding the middle obstacle to the right, and when it flew back, then it avoided the same obstacle on the same side, right, to the east, so to speak. But if they rotate the scenery further by 27 degrees, suddenly the drone avoided the obstacle to the left. So this was an unstable behavior, and then they started wondering when will this behavior change, and found the angle of 25 degrees plus a little bit, where the drone flew directly into the obstacle and crashed. Right, so this is the kind of defects you can detect in such cases. Another example of artificial intelligence testing was conducted by Tian and others, who took the most the top performing deep neural networks of a self-driving car challenge named Udacity Self-Driving Car Challenge. And they tested these autonomous vehicle control systems, checking whether the correct driving behavior is occurring in different situations. And what they did is they took a simple driving scenery, and then they added some camera conditions like rain falling or fog or blurring or picture scale shifts and so on. And here is, and you can see all their results in the internet on GitHub. They have also developed a framework for this testing system, the deep learning test. So they published it on the GitHub, and you can see it. And here is the first example that they published. The source test case is driving on a country road with a light left curve ahead and with oncoming traffic. No problems, the control system is behaving correctly. But then if you add a rain to the camera, suddenly the control system takes the curve too early, driving right into the oncoming traffic, which can of course cause severe or even fatal accidents. So my recommendation is, before onboarding a self-driving vehicle, look at this site and look what can happen. So after having fun with failures, let's look at the methodology side. So what is metamorphic testing? Basically, I would say it's a test technique, and it's usually a black box test technique. To discuss this, I included the entity relationship model that we developed at the ISTQB Glossary Working Group with the main work products of test design. And we have as swim lanes, as vertical swim lanes, the main activities of testing, test analysis, design, implementation, and execution. And the boxes represent the main entities which we develop. And in this case, in metamorphic testing, the test basis is mostly the specification. Sometimes we also use white box elements like the neurons in the neuronal network, but the most important one is the specification. The metamorphic relations are derived from the specification, and they constitute our test conditions. These are the situation that we want to cover, right? The metamorphic relations, like the car should behave the same whether it's raining or not. From this we derive test cases. Well, the test cases do not contain expected results or post conditions indeed, but I would still call them test cases, the source and follow-up test cases. And from then on, it's the same procedure as usual. So we derive the test procedures with these sequences of source test case and follow-up test case, and then test suites and run them and get the actual results, which should be traceable back to the metamorphic relation. So we should be able to state whether the metamorphic relation is passed or failed. Among these activities, of course, test analysis is the most demanding and the most human activity, let's say. It determines indeed the effectiveness of defect detection. If we find the right metamorphic relations, then we have a great chance to find many defects. It is an essentially creative activity and human. It needs the knowledge of the application domains. It requires also the ability for functionally decomposing this knowledge to relations and to specify those relations formally, especially if we want to use them in a model-based testing environment. It has two approaches. We can start out from the inputs and ask ourselves which change of the input leads to verifiable changes of the output, or the other way around, start from the output and ask ourselves when are the expected outputs identical or equivalent or partitioning and so on. But essentially, we have really to invest intellectual power here. Another interesting question related to metamorphic testing, and that will be my last aspect, is what are the test end criteria? So one is, have we tested enough, right? When did we run enough test cases? And the ISO standard states that there is currently no industry-agreed approach to calculating coverage for metamorphic testing. So we need alternatives to that. But in the case studies, we've seen that there are two options to use. One of them is rather a brute force option, but the defect detection rate, to run as many low-level test cases for a metamorphic relation until we stop finding new defects in packages of 100 or whatsoever. And the other more intelligent option is to combine it with white box coverage, like the coverage of neurons in artificial or deep learning systems. So my conclusion is that metamorphic testing has proven its value. It's relatively new, even not very new, but it's relatively new for the practice. It's especially suitable for test subjects with a relevant Oracle problems like web services or artificial intelligence. It integrates well with model-based testing with agility and DevOps. And the defect detection effectiveness is really depending on the analysis, but it's empirically proven that you can detect many defects. And if you want to use it efficiently, you must use a high degree of automation, generating inputs and verifying the relations and so on. It should all be automated. So my conclusion is here, I would like to appeal to you to apply metamorphic testing in your practice as soon as you encounter an Oracle problem. Thank you for your attention, and I'm happy to answer questions.
So thank you, Matthias, for this very interesting talk on metamorphic testing. So we have a bunch of questions here. First thing is, if I got it right, a metamorphic relation is always a subset of your initial test case, right? So your follow-up test cases are subsets of, or the results are subsets of your initial test case.
No, it can be all kinds of relations. So the follow-up test case could be, the relation could be that the result of the follow-up test case is twice the output of the initial test case. In my examples, indeed, it were subsets, but it can be something different.
Only in the examples here. Yeah.
Yes.
So how many inputs do you need for metamorphic relation in that case?
This is a very good question, because as soon as you just partially check the validity of the input, of the output, you need to run several low-level test cases for the same high-level situation or high-level test case, right? And so usually you run many. In my own example, I didn't start out with test. I tried out many strings until I found out that test is covering them all. So usually in metamorphic testing, you are running many, so hundreds of low-level test cases for one relation. You generate them and then you run them.
Okay, thank you. You also mentioned that this technique is already part of the new artificial intelligence testing syllabus. So as you are the PO of the test analyst syllabus, can we expect to have this technique in a major update of this syllabus in the future as well? Can we already talk about that?
I'm planning to issue a major update of the syllabus. I cannot tell you when it will be released because it depends on many things. ISTQB has to decide to develop it first, and then we will get a schedule. My main objective with the new development is to improve the quality of the syllabus, and rather than to be ready in time. So I can't give you a forecast about when, but we will start. Basically, at ISTQB, we have the idea that after 5 years after the last major version, which was in 2019, we might issue a new syllabus, but that's only the ideal case. Okay. We usually get it out later.
But either way, it will make sense to get deeper into this technique because it's just useful and a good complementary technique to the ones we already know and have in place in the industry.
Exactly, definitely. So I can promise that I will include it in the next version. I just can't tell you when.
Okay, but it will be somewhere in the future.
In the near future.
Okay. Yeah. Does that all fit also in an agile life cycle? So this technique as part of agile development?
Yeah, good question. It fits very well as the case study of Lindvall and the others at NASA has proven. That what they emphasize there is that with agility, you need to design your test cases such that you can immediately automate them and then run them in the next increments or next iterations, and that's what they succeeded to do. And there is much automation in metamorphic testing. So yes, it fits very well. Actually, it fits into shift left. It fits into continuous testing because you're running automatically in your CI/CD these test cases.
Okay, great. So thank you very much, Matthias, for this interesting talk on metamorphic testing.
You're welcome.
Have a good day in Marrakesh, and we'll be back in nearly 10 minutes with our next presentation by our member, Horst Pullman. See you.
Bye.